All right, let's talk about RDF, the Resource Description Framework. You've probably heard the term thrown around, especially when people talk about the semantic web. But what is it really? Why is it such a big deal for building a smarter, more connected web? Well, today we're going to pull back the curtain and demystify it.
Think about the web as it is now. It's amazing, right? Billions of pages, all linked together for us humans to read. When you and I see a page about the Mona Lisa, our brains instantly connect the dots. That's a famous painting. Leonardo da Vinci was the artist. It's in the Louvre. But a computer, it just sees a bunch of text. It doesn't get the meaning. So that's the fundamental problem RDF was built to solve. How do we get machines to actually understand all this information? So here's our game plan. We'll start with the big picture idea, a web built for machines. Then we'll dive into its core building block, the simple triple. We'll see how that abstract idea gets turned into actual code, find out how we add real meaning to it with vocabularies, and finally, see how it all comes together in the incredible concept of linked data.
Okay, first up, a web for machines. The vision here is massive. It's about shifting our whole perspective. Instead of just thinking of the web as a giant collection of documents for people to look at, imagine it as a single global database. A web where information is structured so that our apps, our software, our AIs can process it, share it, and understand it automatically.
And that brings us to the official definition. RDF is a framework, a standard from the W3C. But the most important part of this whole sentence is right at the end, without loss of meaning. That's the whole ballgame. It's not just about shuffling data around, it's about creating a common language so when one system sends information to another, the context, the relationships, the meaning, it all stays perfectly intact. That's how you get true interoperability.
So, how does RDF actually achieve this? How does it create this common language? Well, it all boils down to one incredibly elegant and simple idea, and that is the triple. This little guy is the atom, the fundamental particle of the entire semantic web. Every single piece of information in the RDF universe is expressed as a triple, and you already know how this works because it's just like a basic sentence. Subject, verb, object. So you have Bob, that's our subject, knows, that's our predicate or the relationship, and Alice, that's our object. Bob knows Alice. It's that simple. This three-part structure is universal, which makes it incredibly easy for a machine to process. No ambiguity, just a clear, simple fact. Now, to make these triples work, we have to distinguish between two kinds of data. First, for the things we're talking about, concepts like a person named Bob or a specific painting like the Mona Lisa, we use something called an IRI. Just think of it as a unique permanent web address for that thing. On the other hand, for simple data values like the text string Mona Lisa or a specific date, we use what's called a literal. And here is the golden rule you have to remember. A literal, a data value, can only be the object of a sentence. It can never be the subject.
And this is where the magic really starts. We can take these simple triples and start chaining them together. So we have a fact, Bob is a friend of Alice. We have another fact, Bob is interested in the Mona Lisa. And a third fact, the Mona Lisa was created by Leonardo da Vinci. Did you see what just happened? The Mona Lisa was the object in one statement, and then it became the subject of the next one. Boom, that's the link. That's how we start weaving individual little facts into this huge connected web, or more accurately, a graph of knowledge.
Okay, so this idea of a graph made of triples is really cool, but it's still just an abstract concept. How do we actually write it down in a file that a computer can read and understand? Well, the technical term for this is serialization.
Before we look at formats, here is a really important idea to grasp about RDF, and the W3C primer says it perfectly. What this means is, you can write the same data down in a bunch of different ways, but as long as they produce the exact same set of subject, predicate, object triples, they mean the exact same thing. The format is just the envelope. The triples are the letter inside.
For example, let's look at two popular ways to write this stuff down. On one hand, you have a format called N-triples. It's super verbose and precise. Every single line is one complete triple, spelling out the full, long web address for everything. It's perfect for computers, but kind of tough for a human to read. That's why we also have Turtle. Turtle is designed for us. It uses clever shortcuts like prefixes for long addresses and semicolons to group facts about the same subject.
It's way more compact and easier on the eyes. But remember, under the hood, they are describing the exact same graph.
Okay, so we can state facts and we can write them down, but there's still a big piece of the puzzle missing. How does a computer know that the relationship FOAF knows means a social connection between people? How does it know what a FOAF person even is? For that, we need a shared dictionary.
And the answer is to use shared vocabularies. Think of a vocabulary like RDF schema or RDFS as the official dictionary and grammar book for our data. It's where we define the rules of the game. We can say things like, the property creator is used to connect a thing to a person. And by using well-known public vocabularies like FOAF for describing people and relationships, or schema.org for describing web content, everyone agrees to use the same terms for the same things. It ensures our data is consistent and, well, meaningful.
And this is the really cool part. This is the payoff. Because we have these shared rules, a system can do something that feels a lot like thinking. Check this out. Step 1, we give the system a fact we know is true. Bob knows Alice. Step 2, the system also knows a rule from our vocabulary. The subject of a knows relationship has to be a person. So, step 3, the system can deduce a brand new fact all on its own. Bob must be a person, even though we never explicitly told it that. This is called inference. It's the system connecting the dots, and it's what makes RDF data so powerful.
So let's zoom all the way out now. We have machine-readable facts, we have shared rules to understand them, and we have systems that can even infer new facts. When you put all of that together and apply it to the entire internet, you get the grand vision, the power of linked data.
Linked data is essentially what happens when you use all these RDF principles at a massive scale. It's the practice of putting data out on the web using these standards, and crucially, linking it to other data. It allows the machine to start at one point, say Bob's profile, follow the data link to the Mona Lisa, and then hop over to a completely different server, a completely different data set to learn more about Leonardo da Vinci, all by just following the data trail.
And the superglue that holds this entire global graph together is one powerful little property: OWL same as. Think about it. Wikipedia's database has one unique ID for Leonardo da Vinci, and the Virtual International Authority file has a completely different one. OWL same as is the magic bridge. It tells any computer, hey, these two different identifiers, they're talking about the exact same person. This is what allows us to merge knowledge from thousands of different sources into one richer, more complete picture. And that really brings us to the final question. RDF isn't just a technology. It's a blueprint for a fundamentally different kind of web, one where knowledge isn't locked away in documents, but flows freely as part of a single connected graph. So I'll leave you with this to think about. What becomes possible? What kinds of questions can we answer? What kinds of services can we build when the entire web works like one giant queryable database of global knowledge?